Okay, so I did my presentation on a few locations in Acadia National Park, which is located off the coast of Maine on Mount Desert Island. The first one is Jordan Pond. I just wanted to zoom in here so you could see a good um, aerial shot of the surrounding mountains and the vegetation and the different plant morphology. So this is a vegetation map here that's from USGS. If we zoom in here, you can see the color-coded system here surrounding Jordan Pond. So there's definitely going to be this upland conifers, mostly dominated by the spruce trees. It's more of like a boreal forest. And then this lighter green color here is going to be an upland forest, but it's going to have more of a mixed in there, some oaks, spruce, birch trees, and stuff like that. Um, and then down here in this corner is going to actually be um, a wetland. It's a type of bog. And then this map here is just a nice shot of the topography. You can see how very steep the mountains are around this pond and how the water is going to move into this system here. So 18,000 years ago, this area was definitely um, carved away by glaciers. You can see these very distinctive U-shaped valleys in the mountains back here. These are very indicative of glacial geomorphology. Uh, and up here in the front of the picture, you're going to see a wide range of glacial till that was left over by these huge sheets of ice that came through here. You'll see cobbles and boulders and some gravel mixed in here in between them. More on the biogeographic side of the Jordan Pond, you can see the very sparsely uh, vegetation within the water, very minimal amounts, and you'll see lining the shoreline over here, the how thick the boulders and cobbles are, and where the vegetation stops, and how thick everything is up and beyond that, and where it's not thick on some of these granite peaks here on the mountains. You'll see this looks right into the water. You can see that mix of that glacial till again, and just how very sparsely the plant vegetation is, very minimal amounts, but definitely like cobbles and gravel. This shot here, you can see before you get to the upland mixed forest, there's definitely a row of shrubs here before you get to this rocky shoreline where there's very minimal amounts of vegetation. Um, and then you'll get to that thicker, denser wooded area behind. But there are some very large boulders along here too, so just gives you an idea of like how these sheets of ice actually were capable of moving and shaping these valleys and these distinctive views and carving out Jordan Pond. Jordan Pond is characterized as an oligotrophic tarn. Oligotrophic on the biogeographic side, and the tarn going to be more of the um, glacial geomorphology. Uh, I had mentioned that there's a wetland, a bog, and this is over here in the corner of the pond. This area is separated from the pond due to the amount of glacial till that was built up, so it creates this slightly dammed area where glacial meltwater systems run off, and uh, the water is very acidic, and that's very indicative to a bog for the reason of the excessive amounts of plant matter from the forest that get pushed into the system and don't have time to decay, and just lots of excessive amounts of decaying plant material in there that causes acidity in the water, lots of sphagnum moss. This is from the other end. I like this because you can see between the tree line here the difference between the upland and the upland mixed forest, and then the the more boreal spruce-dominated upland forest, and this line difference because the trees are changing and the spruces don't change color. Back to the vegetative map, we're going to zoom into my second location, which is going to be near Sand Beach and Beehive Lagoon. You'll see that's right here. So this is an aerial shot. This is an aerial shot of the Sand Beach, and this is Beehive Lagoon here. So this is another area that it's was definitely carved out. You'll see these high cliff sides on each side. The glacier came through here and carved this out and made these very distinctive melt wave patterns for the fluvial geomorphology to cause this lagoon to build up here and make its way through a tidal creek to the ocean. There's a lot of different vegetation here due to the different habitats. And you can kind of see the difference between this. We have some dunes behind here that meet the forest behind it. And then the mud flats are down here closer where this runs out to the tidal creek. And these are going to be more of a brackish water. And this is considered a saltwater marsh on the biogeographic side. It's going to be fed from the freshwater glacial melt from the runoff from the mountains behind. But it does have a mix of saltwater from the closeness of the ocean, obviously. This is another system. You can see the change in these tidal creeks in the way that as it moves through the deposition of this tidal creek and water system, creates sandbars, moves the sand is pushed up from the other side, from the ocean. And then you'll definitely see the dunes here and the difference between the vegetation. Again, when you get to that more wetland area here, you'll see the dune grasses stop and you'll get to the more wetland plants, the reeds and rushes. And you can see too that the deposition here of this little tidal creek that moves through here, you can see it moves gravel and stones and some cobbles that come from these mountains behind it when the water has enough energy to move it and transport it down here where it's deposited. And you can see in here there's definitely some wetland plants that are more indicative to this marsh system, the saltwater marsh system, and these here in the middle are going to only grow there because they're only capable of being in there, and then these grasses and stuff up here on the dunes and the sides of this wetlands over here are going to be completely different. And then this is just it coming out into the water here. The tidal creek moving into the ocean. And if I zoom in on the creek here, you can change the time scales, and this has been aerial recorded for a very long time, so you can see the definite changes of this system. You'll see how the water system that moves out to the ocean definitely changes. Structures form like sandbars here in the marsh itself, just deposition and sediments that are moved down through the system and transported, build up. Sometimes there's more snow, so there's a lot more melt. Here, it's very dried out. You can see the sand on the bottom, but then sometimes it floods and gets much more full and swollen, and you can see the system that feeds it down into here as well.